Hey, Algebra 2. This is Mr. Osborne. I'm going to be going over your final review, Part 2. So make sure you have this worksheet and not Part 1. Alright, so the first thing is we're going to be graphing this function. This is a rational function. If you see 1 over something that has x and maybe plus or minus a number like this 4, you know it's a rational. You know you're going to have a graph that looks like this. You're going to have an asymptote going vertically and an asymptote going horizontally. And then you'll have two lines that either go up and then across on the top side, and then on the opposite or side from that, you'll have another line doing the same thing. So let's go ahead and graph this one. So the first thing you do is you look at the part of the rational on the bottom, the denominator, where it says x plus or minus whatever number. If it is a plus 4, then that means your asymptote is negative 4, because remember x is a liar. So you will have an asymptote at negative 4, and then you will have an asymptote going horizontally at the outside number, which is negative 2. And that one is just whatever it is. If it's negative, it's negative 2. If it's positive, it's positive 2. Okay, so now you go ahead and graph those asymptotes. So I have one at negative 4. And then one at y equals negative 2. Okay, now you need anchor points. You need to know where to start these lines at. So to do that, I'm going to pick a point to the right of the center of our asymptotes. So that would be, let's do a little mini table over here. That would be negative 3 and negative 5. So I'm picking x values to the left and to the right, so I know where to put these anchors. So what I'm going to do is I'm going to plug in that negative 3 into the function and see what I get. So you just basically plug in the negative 3 for the x. So negative 3 plus 4, that's going to be 1, and that's 1 over 1, which is still 1, and then 1 minus 2 will give us negative 1. So that means our first anchor point will be here at negative 1 on this side. And then for the other, I know the other is going to be right across from it, but just to double check and show you, if I plug in negative 5, well, that will be plus 4 will be negative 1. So then this becomes 1 over negative 1, which is just negative 1. And then negative 1 minus 2 is negative 3. So at negative 5, put it here at 3. And then if this is your anchor point, that means your graph is going to start here and approach the asymptote and get really close but never actually touch it. And then it's going to go really close to this asymptote but never touch it, and do the same thing here. Okay? And it's kind of a little bit of a curve right here, right where there's an anchor, or right at the anchor point. Okay? Now this one, we need to solve this. We need to find what is x equal to. Okay? Well, I have a radical here, and I need to get rid of it. In order to get rid of it, I need to raise each side to a power, and that power is determined by whatever your index is on the radical, which is in this case 4. So if it's 4, I'm going to raise this to 4, and then that will cancel out the radical. So now I have x plus 1 equals 3 to the 4th, and 3 to the 4th is 81. And then just solve what you have left. So now subtract 1, x equals 80. Okay, you notice I actually went from 1 to 5, so now I'm going to number 2. So now number 2, I need to solve this radical. Okay, so what I want to do here in this rational function or rational equation is first, when I get an answer, I want to double check to see if there's an answer that will make these denominators 0. Because if the denominator is 0, Elijah, shh, then that makes this undefined, and we don't want that. So I think to myself, what number could I plug into x to make it 0? Well, just 0. I plug in 0 here, it's 0. Plug in 0 here, it's 0. Plug in 0 here, it's 0. Okay, so now I'm going to rewrite the equation. And I'm going to write it out by kind of spreading things out. And I do this to kind of leave myself room because I'm going to be multiplying a lot. And I'm also going to break down the variable. If it's like a squared variable or a cubed variable or just some variable raised to a certain power, I'm going to spread it out so it makes it easier to go through this problem. Okay. So now what I want to do is get rid of these denominators. It's going to make it a whole lot easier to solve. And so I have to say to myself, what do I multiply times this first term to get rid of the 8? Well, just 8. And then I have to multiply x to get rid of x. But again, if I do that here, I have to do it all the way across. And I'm going to multiply 8 and x all the way across. And then I go to the next term. Will 8 cancel out the 2? Yes, it will. Will the x cancel out this x? Yes. Will 8 cancel out anything here? No. Will the x cancel out everything here? No. It only cancels out 1, so I need to multiply 1 more x. And again, I have to do that everywhere. Okay, now what I can do is go ahead and cancel out. So that it's 8, these 8's go away, these x's go away, and I have just one x. This 8 and 2 go away, but then it's 8 over 2, so that gives us 4. And then x and x, and then we have 1x here. And then the 8 stays. This x gets rid of this x gets rid of this x. Elijah! Shh. Quiet, please. Okay. Alright, sorry about that, guys. Getting ready for the Warriors game. That's my son playing basketball. Alright, so what we're going to do here is pretty much carry down everything that was left over after we canceled out. So here I had an x equals, and then I had a 4 times an x and minus, I only had an 8 left over here. And then I just solve the equation. Okay, one of my variables on the left, so I'll subtract 4x. And remember, this is a 1, so it's basically 1 minus 4, which is negative 3. And I have negative 8 here. Divide both sides by negative 3. And x equals 8 over 3. And 8 over 3 is not 0, or that extraneous value that I originally found, so that's our answer. Okay. Now let's go down here, simplifying this radical, because it's rad. You guys love radicals, right? Alright, so what you want to do here, remember, is the birthday cake. But just remember, if you have a negative inside, pull out a negative 1, okay, as you're breaking this down, okay? So first, let's break down the 128 off to the side with our birthday cake method. Divide the smallest prime number you can, and that's 2. That divided by 2 is 64. Then again, the smallest prime number is 2 here, and that gives us 32. And it can keep going with 2. And that gives me 16. 2 again. And then 8. And just remember, it's not always going to be 2. It could be 3, it could be 5, 7, just as long as it's the prime number. Okay. 2 again. 4. 2 again. 2. And then finally, I can only divide 2, and I'm left with 1. Or like we said, that's why it's a birthday cake, because the top is our candle. Okay, so now I have a lot of 2's. Okay, so what I want to do is circle groups of 2's, and the amount in each group is determined by, remember, the index. So the index is 3, so I'm going to circle groups of 3. There's one group, there's another, and then remember I have 1 left over. Okay. All right, so that means is that from each of these groups I will take out 1, 2. Okay, and the rest will just kind of cancel out. Okay, so then what I'm going to end up with here is in my radical, I'll have 2 2's on the outside, and you multiplied it, okay? But then also, I have a negative 1 because this number is negative. And this is only when the number is negative, okay? If it's positive, you don't have to worry about the negative 1. Don't forget your index, it's 3. Now, you have to think about it. If you took the cube root of negative 1, what would it be? Well, negative 1 times negative 1, or negative 1 times negative 1 times negative 1 is still negative 1. So the cube root of negative 1 is negative 1. Okay? So I can just take out a negative 1, bring it outside. Okay? And then I still have a 2 inside. Oops. Remember that 2 up here on the top. And now I have to look at the x to the 7th and y to the 2nd. Well, really, if you remember what you do here is you just take the amount of x's here, 7, divide it by 3,
and there's 2 of them. So actually first let's write this down so we can kind of do this one step at a time. Okay, so I can divide 3 into 7 2 times, so that means I'll bring out 2 x's. 1 and 2. But then there's a remainder of 1 when you divide 3 into 7. So that means I'll still have 1 x on the inside. And then don't forget to write your index. Oops, sorry. So put that in a different color just so you can see it. Don't forget to write the index on every step. Okay. And that we still had that 2 in there. We had 1 x left over. And then for the y's, I can't divide 3 into 2. 2 is too small. So there's no groups of 3 y's I can even take out. Okay. So that's what I'll have inside. But now we have to multiply all these terms on the outside. So 2 times 2 times 1 is negative 4. And then x times x is x squared. 2 times x times y. And then don't forget our index. Okay? So the biggest thing was first look at that number, break it down with the birthday cake method. Every time, and then look at the index. That will tell us how many we circle. And from each of those groups, you take out one of those numbers. That's where the 2's came from. And if you have a negative, then take out a negative 1. And then if you don't, then you don't have to do that step. And then look at the variables and divide the number or the exponent by the index. And if you however many you get when you divide, that's what goes outside, and the remainder stays inside. Okay? All right, so now here. Now you would think here I could just multiply this times this, 1 square root times, or 1 radical times the other. However, so if these indexes were the same, I could just combine the 2 and then multiply the inside, but they're not. So what I have to do is basically just simplify each radical separately. I'm going to simplify this one, and then simplify this one, and then combine them in the end. Alright, so now let's work on this one here. And again, remember I told you you do the exponent divided by the index. So 7 divided by 4, well, 4 only goes in once, and I have a remainder of 3. So that means I can take out 1x, and remember write the index, and then the remainder is 3. So I have x to the third on the inside. Sorry. Okay, that's the first one. Then the second one, 10 divided by 5, well that's 2, so that'll be x squared. And if it divides perfectly, in other words you have nothing left, no remainder, then the radical's gone. You don't have any more radical. Okay, so now, what you can multiply here or combine is this term on the outside with this term. Okay, because they're both outside of a radical, so you can combine them. Remember, this is not x to the 4th, but that's just the index for it. This is x times x squared. So my final answer would be x cubed times the 4th root of x cubed. Okay? Okay, let's go back up to number 5. I already did that one. So let's go down to number 6. Kind of skipped ahead and did number 5 earlier. Okay, use the given measurements to solve this triangle. Okay, this is where, when you solve the triangle, you had to use law of sines, law of cosines, and that sort of thing. Okay, so remember, the first thing you want to try is the law of sines. Law of sines can be written this way, a over the sine of a equals b over sine of b. And these are usually pretty easy to remember because it's just basically just the same letter over the same letter, right? Okay, remember you can flip that too. You can flip the other way. You can put the sign on the top. Okay, so what you then you want to try the law of cosine. But let's try the law of sines before we get into that first. So in order to do the law of sines, remember you need a pair, an opposite side with an opposite angle, and you have that here. You have the 29 and the 83. Okay, and then we also have this angle 36. So what we'd want to start with is, well, let's find this pair, the v's. We have the e's, but let's find the v's. Okay, so we're looking for a side. Whatever you're looking for, put that on the top. Okay, we're looking for the side, so we'll put the sides on the top. So that v over the sine of 36 is equal to 29. Now I'm going to use this pair, the e's, over the sine of that opposite angle, which is 83. Okay. So now, just cross multiply. And remember, when you multiply, cross multiply, you don't have to multiply this v to this sign down here. You could just go ahead and move this sign up here. Okay? And you get the same result. So now it's v. And if you want to cross multiply and then divide both sides by, what you have to do, it's fine. If that's what you're used to. But this could be a little easier for you. So now 29 times the sine of 36 over the sine of 83. Okay, so let's go to our calculator and punch in. Okay, let's see, we do 29, and I'll do parentheses, times the sine of 36, parentheses around all that, then divide by sine of 83. Okay, and that looks like it matches up to what I have over here. So I'll go ahead and hit the equal sign. Okay, so now let's go ahead and round. Oh, it says round to the nearest tenth. So let's round to the nearest tenth, which is the 7. Look to the right. 3 doesn't change the 7, so 17.17. Okay. So v is equal to 17.17. And it doesn't have a measure, so it's just 17.17. Okay? Okay, so, but we're still not done yet. We need to find not only that side, v, but we need to find side c and angle c. Okay, so we don't know either of those. But I can find angle c because I know the inside of a triangle adds up to 180. Okay, so basically I'm going to do 180 minus the other two angles, 83 plus 36. Okay, pull out the calculator real quick. Because I like to use calculators, nothing wrong with that. 180 minus 83 plus 36. Oops. Okay. And the angle is 61. So that angle C is 61. Okay. 61 degrees. And so now, to find C, I have a pair because I have angle C. So let's set up law of sines again. Side C over sine of its opposite angle. And then I can just pick either the E's or the V's, but I'll choose E just because that's the safest. I know for sure that's going to be a correct pair because it's already given. Because what if you made a mistake? What if you messed up on the V's? And at least you'll get it partly correct, you know. Okay, so now, again, cross multiply, but again I can just bring this up here. So now it's C equals 29 times the sine of 61 over sine of 83. Okay, so let's go ahead and do that in our calculator. Okay, so now, get rid of this. 29 times, I always like to do parentheses when I separate my different operations, times the sine of 61 divided by the sine of 83. And I get 25, remember round to the nearest tenth, so the tenth is at the 5. The 4 is not going to change anything. So it's just going to be 25.55. 25.55, and that's the last thing we needed to find. Okay? Alright. Number 7. What is the amplitude of the following equation? Where does the amplitude come from? Simply the number that's in front of your cosine or sine function. So it's 3. That's it. 3. Or we'll say amp equals 3. Okay, that was easy. All right, so now, number 8. Theta, which is some angle, is an acute angle. Remember, an acute means less than 90. Okay, it's less than 90 degrees. Okay, find the value of theta in degrees if the inverse sine of this value is equal to theta. So, in other words, okay, so now for this one, what I need is a unit circle. So basically I need to look for an angle that's less than 90 degrees, and that the y value at that angle is square root of 3 over 2. Okay, so if I go over to the unit circle, and I'm looking in this area here, where it's less than 90 degrees. Where is the y value square root of 3 over 2? Right here at 60 degrees. Okay, so that's the answer to that one. Okay, 60 degrees. And then here, I'm looking for an angle where the cosine is radical 2 over 2. Remember, the cosine is the x value. And again, it's acute, so it's got to be over in this region. So where's the x value rad 2 over 2? Well, right here in the middle at 45. Okay. Okay, number 8. Find the area of the triangle, round to the nearest tenth. Okay, so you got a couple different formulas you can use. You have the 1/2 times BC times sine of A. That's not going to work because we need an angle. So we need to use the other one, Perron's formula, where you do the square root of S times S minus A, and S minus B, and times S minus C. And this will give us the area. But we need to first find the S to plug in. And the S is basically half of the perimeter. So what you do is you add up all the sides, A plus B plus C, and then multiply times 1/2. So really what you do is just do 7.7 plus 20 plus 25, and then multiply all that times 1/2. So let's do it on the calculator. Let's go back to our calculator here. Okay, so now we're going to do, move that over so you can see it. So we're going to do 1 over 2. Actually, let's do it this way. Let's do it in parentheses and make sure the calculator recognizes it's 1/2 times 7.7 plus 20 plus 25. Okay, that looks good. So that will be our S. Okay, and it's about 26.35. Okay, so S equals 26.35. Okay, now take your S and set up the formula. Okay, so 26.35 times 26.35, because remember it's S minus the first, minus whatever side you choose first. Then again 26.35 minus the next side. Then again 26.35 minus the next side. Okay. Then we go ahead and plug that in. Our calculator. Okay, so we're going to do the square root of 26.35 times 26.35 minus 7.7. This is where it can get tricky. Just make sure you don't make mistakes plugging it in to the calculator. 0.35 minus 20 times 26.35 minus 25. And I'll zoom out here to make sure we got that correctly, or done correct. Okay. So it just looks like the calculator won't let me look at it any further, but it looks good. Oh yeah, that's right. We need to do one last parentheses. Okay. To surround everything. And one last double check. And the area is the online calculator, I think, didn't like that I was punching in so many numbers. But the calculators at school will be able to handle that. Okay, so basically I just multiplied everything on the inside separately, and then now I'm going to take the square root of it, and that will give us 64.9. We were on to the nearest tenth, so 64.9. And I just realized that on the last problems, I was not rounding to the tenth, I was rounding to the hundredth. So I apologize for you guys that are like, "What are you doing, Mr. Osborne? You are rounding to the hundredth, not the tenth." Okay, so let's round to the tenth, like properly, 64.9. It's funny how in math, sometimes you realize you do things later on, but hey, that's the beauty of it. We can all be forgiven, right? Alright, so there we go, 64.9. Okay, so now what are the coordinates of the vertex of this parabola? Well, you remember that x is a liar. So the x comes from the value next to x, which is right there. But x is a liar, so it's -1. And the y value doesn't change, it's -5. Or basically the value that's outside of the parentheses, away from the variable, does not change, so it's -5. Okay, convert this to radians. In order to convert this to radians, I multiply it times pi over 180. And then if I want to go the other way, convert back to degrees, remember I multiply it times basically the same thing, the reciprocal of that, 180 over pi. Okay, so now 135 over 180. And you're going to have to reduce this, so let's go ahead and start reducing. I know that now I know that 45 goes into both, but let's say you just don't know, right? Okay, so let's start with 5. Okay, I'll divide 5 into both of them. Okay, that's going to give us, so 135 divided by 5. It's going to give us 27. And then, so 27 pi. And then 180, 180 divided by 5 be 36. Okay, then I got to keep going because I can divide into both of those. Okay, I think the biggest number I could divide there would be 9. Okay, so now that would be 3 over 4. So 3 over 4 pi. Because we don't want to convert that to decimal. That's not really useful for us. We want to keep it in fraction form. Okay. Now, given this formula for infinite series, find the sum of the infinite geometric series. Well, first we need to know the first term, and we need to know the ratio. Okay, well we know the first term is 27, and we can find the ratio by taking the next number in line divided by the previous one, so 9 over 27, and that will be 1/3. And just to confirm it, to make sure we're right, do the next term divided by the previous, so 3 over 9, so yes, that's 1/3. Okay, so now what you'll do, let's set this up. First term on top, 1 minus 1/3. Okay. Need a band-aid? Alright, take a time out. Okay, so let me get this out the way. Okay. Okay, so now to finish this off, in order to subtract do 1 minus 1/3, we need to convert 1/3 to a fraction. Okay, so I know that 1 is also the same as 3 over 3. So I'll just change that to 3 over 3. And now they have the same denominator. Okay, so now, and whatever the 1 is and whatever the fraction is over here, just change it to whatever the same denominator, and you can put the same number on top. Okay, so now 3 minus 1 is 2, so now 2/3. In order to divide this is the same thing as 27 divided by 2 over 3. And remember, when you divide a fraction, you flip it. So now this is 27, and then change it to multiplication. So now this is 27 times 3 over 2. And so then 27 times 3, that's 81 over 2. Okay, and that's the sum. Okay, so now, go up here. What are the coordinates of the vertices of the major axis of this? Well, first of all, what is it? Okay, well, I can rule out one, it's not a parabola, because I have two square terms. Not that. I know it's not a hyperbola,
because if it was a hyperbola, it'd have a minus in the middle, so not that one. So that means it's either a circle or an ellipse. I know it's not a circle either because I have two different denominators, so we know it's an ellipse. What kind of ellipse? Okay, so we look at the bigger number, and that happens to be 36, and it's under y, so that means that it's a vertical parabola. Okay, and the center is at 0 and 0 because there's no, this is not broken up into x minus 2 or x plus 2 and y plus 3, so it's just simply 0 and 0. Okay, so if 0, 0 is the center of our ellipse, that's this point, the vertices are the points at the on the ends of the major axis, the longer side. Okay, the point up here at the top and the point here at the bottom. So the question is, how far is it from the center to that point? That'll tell us those vertices. Okay, I get that from going to that same 36. Okay, because it's under y, so that means that's the value that tells us whether we're going to go up or down. And we take the square root of that, 36, and that's 6. Okay, so that's actually our b. b is equal to 6. Okay, so we go up 6 and down 6. And if we're going up and down, remember that changes the y value. So if I go up 6, that means I'm going to 0, 6. And if I go down 6, that means I'm going to negative 6. Okay, so there's our coordinates for the vertices. Okay, find the total amount when 3,000 is invested at a rate of 8% and compounded monthly for 12 years. Okay, so first we know to do monthly, then we have to do yearly and quarterly. So first for the monthly, the principal is what we started with, the 3,000. And then remember, we're just plugging in the values. And then the rate is 8%. But remember, we need to convert percent to a decimal. And we do that by moving the decimal 2 places to the left. So now it's 0.08. Remember, this is very important. Don't forget that step. So that's what goes on top. Then the bottom, the n, is if it's compounded, either monthly, yearly, or quarterly, then we need to put a value down here. For monthly, well, a year is broken up into 12, or 12 months, so that means we put a 12 here. And then we also put that same n value here at the top, 12, for the exponent, times the time, which is 12. It's also 12 years, okay? And that will tell us what it is for the, if it's compounded monthly for 12 years. Now, what would it be if it was yearly? Okay, same principle. 1 plus same rate, 0.08. But this time, if it's yearly, well, then that's just 1 year over 1. And really, you don't even need to use the special equation, but you can just put 1 anyways. And then 1 times the 12 years. Now, quarterly. Quarterly is a year broken up into 4 parts. So n is equal to 4. So now, I'm going to put it over 4 for n, and 4 up here as well. Okay, and I basically just have to figure out what these values are. Okay, so let's do that on the calculator. Okay, so let's do the first one, the monthly one. Okay, so the monthly, 3,000 times 1 plus 0.08 divided by 12. And then that's going to be raised to, so where's the exponent? Right here. 12 times, actually let's make sure the computer recognizes that these are both exponents. Sorry. So we'll put that in parentheses, 12 times 12. So the total here is going to be $7,810. And this is dollars and cents, so we want to go to the nearest hundredth, so, and 17 cents. Okay, now we're going to do the same thing with the next one. Okay, so 3,000 times 1 plus 0.08 divided by 1. I didn't really need to do that 1, but I just did it anyways. Raised to the power of 1 times 12, which is just 12. Oops, not 11. So then I get, oops. Okay, let's try it one more time. Okay, 3,000 then 1 plus, and we don't need to do the 1, so we'll just do 0.08. Okay, and then raise that to the power of, let's do the 12 in parentheses, just to make sure it knows what I'm doing. And there we go. $7,554.51. Okay, so that's how much it is if we do it quarterly. Move this over a little bit. Okay, I'm sorry, that was yearly. I apologize, that was the yearly. Okay, now let's do the next one down here. 3,000 times 1 plus 0.08 divided by 4 raised to the 4 times 12, which is 48. And that will give us 761.21. And as you can see, the first one gave us the most, so doing a compounded monthly gives us the most bang for our buck. Okay, so let's move back over here. Okay, so now, and that was it. That's all we had to do. Okay, find the total amount that we make after that, so many years. Okay, now find the amplitude of this following graph. Okay, so remember the amplitude is the distance from the center axis of your cosine or sine graph to the top. Or it's simply the half the distance from a minimum of your graph to a maximum. So right now, what we should do is just find the distance from one minimum to the maximum. Well, this minimum here goes down to 1, -1, -2, -3, -4. And it goes all the way up to +2. That total distance is 6. But again, amplitude is equal to half of that, so our amplitude is 3. Okay? Graph the following. Okay, so graph sine of x. Okay, so let's do that here. And I'm going to do the cosine all together on 1, and I'm going to do the sines all together on 1. Okay, so first for sine of x, we're going to do pi over 2, then it'll go to pi, then 3 halves pi, and then 2 pi. Okay, and we'll have a mark for 1, -1, and 2. Okay. Okay, so for sine of x, the first function, remember sine starts in the middle, right at the origin. It goes all the way up to 1 at pi over 2. Then it comes back down to pi, or basically 0. And then at 3 halves pi, it goes down to -1. And then it goes back at 2 pi, it goes back up to 0. So it does this kind of oscillating up and down curve. All right, now for 2 sine x, the amplitude has changed because that's the first number, and instead of going up to 1, now it's going to go up to 2. But it will still come back to the same point in the middle. But now it will go down to 2 from there. Down to -2, and still come back to the same point in the middle. Okay, so now you'll have a sine curve that looks like this. Okay. Now for cosine, let's do our scale. Pi over 2, pi, 3 halves pi, and then 2 pi, and then again 1 and 2, and then -1 and -2. Okay. So first we'll do the negative cosine. Well, usually cosine starts here, comes down. Just kind of doing a quick little sketch of just regular cosine. Oops, sorry, not at 2. It doesn't start there. Usually starts at 1, comes down to the center, or the axis. Then at pi, goes down to 1, -1. Then it comes back up at 3 halves pi, it goes back to the middle. And then at 2 pi, it goes back up to 1. Okay. But here it's negative. Remember, a negative in front of your function flips it. So it's not going to start at 1, but it's going to flip down and start here. So now you'll start here at
at 1, go through the same point, but then go up to 1, and then come back down to 0, and then go back down to -1 like where it started. So then my final graph looks like that. Now, we're going to do -2 cosine. So again, has that same pattern, starts below because it's negative. And it's going to go back to the center, just like before. But instead of going up to 1, now it goes up to 2. Comes back down through the center again, or through the middle axis. Instead of going down to 1, now it goes down to 2. Okay? Alright, so now this one, solve. So just like that last radical problem we had where we had to solve, again, you want to pay attention to what's the index here. Well, again, if there's no index written, you know it's 2. So that means we're going to multiply both sides, or raise both sides to the power of 2. Okay, so now the radical goes away on this side. And this x plus 3 squared, so that means it's x plus 3 multiplied twice. Okay, so let's do the math here. Okay, we have to FOIL that, so we get x squared. And then remember we add the two terms in the middle, or these two terms, 3 and 3. So 3 plus 3 is 6, and then multiply the last two, 9. Okay, so now we need to, if you see an x squared term, the important thing is when you solve equations, if you see an x squared or y squared, you need to move everything over to one side, because you're going to have to factor to find your answer. So that means I'm going to subtract this 14 from here, and this 2x from here. 2x will be subtracted here, and negative 14 from here. Okay. Okay, so now I have 0 equals x squared plus 4x, and then 9 minus 14 is minus 5. And now I could just factor that, do my quick x, and this will be x, and I know 5 times 1 equals 5, and it has to be negative, so one of these has to be negative. Well, 4 is positive, so that means the 1 has to be negative. And then remember, x is a liar, so x is equal to negative 5 and positive 1. Okay, but then you want to double check, make sure that these are not extraneous solutions, so plug them back in, check your answer. So I'm going to check my answer over here. First I'm going to do this with the 5. Because if one of them doesn't work, then that answer doesn't count. Okay, so I plugged in the 5. So now 2 times 5 is 10 plus 14 is 24. Square root of 24. And then over here is 8. Uh-oh. Oh, sorry. That's actually should have been negative 10. So negative 10 plus 14. Negative 10 plus 14 would be 4. Okay. And then the square root of 4 is 2 equal to 8. That doesn't work. So you know that one doesn't work. So that's why we have to check. Okay, so let's go ahead and plug in the 1. So now we have 2 times 1 plus 14. And usually when you get two answers in these quadratic, when you have a quadratic and you have to solve for x, one of them is not going to work, most likely. Okay, so that's why you want to check it. So now 2 times 1 is 2, plus 14, 16. So then square root of 16, 1 plus 3. And you guys already know that square root of 16 is 4, so that does work. So your only answer is x equals 1. Okay? And I believe that is it. Good luck. See you guys.